Okay. All right. Once again, Assalamu alaikum. We're gonna
Welcome.
discuss waves now. And so, what comes in your mind when you hear the word waves?
The disturbance in the sound medium.
The disturbance in the medium. Okay. Disturbance in the medium. Right. Anyone? Yes. Any other? Do waves carry energy? Yeah.
Yes, sir.
So they carry energy, right? Yeah.
Yes.
When they carry energy, do they transfer energy as well?
Yes, sir.
Tai, what do you think? Can
Yeah,
waves transfer energy? Yeah. So waves transfer energy without without transferring without transferring matter, right? What do you mean by matter? For example, if I have a water here and here the water waves. So what happens from one point to another point, from one point to another point, the energy transverse takes place due to the vibrations, right? Yeah. Yes.
Yes, sir.
The energy, the energy transfer, okay, from A to B, A to B due to vibrations, or we call oscillations, right? So waves are of two types. Okay. Types of waves. Type of waves. The types of waves are,
The transverse waves and
yes,
longitudinal waves.
transverse waves and longitudinal waves, right? Now, the transfer waves, you know, when when the when the particles when the particles vibrate, perpendicular, right? Perpendicular to the direction of energy transfer. So that means if if the energy is being transferred from this point A to B, yeah, so the particle is going to vibrate up and down, okay, which makes 90 degree, okay, which makes the
Yes, sir.
90-degree angle with the direction of energy transfer. So here is direction of energy transfer, right? Okay. And here is the vibration of particles. Vibration of particles, right? Now, when we talk about the longitudinal waves, so longitudinal waves are when the particles. Yes, Marine, would you like to please give me the input? How the longitudinal waves are produced?
Yeah. So, um,
Examples like include sound and p-seismic waves, and the particles move perpendicular to the direction of energy.
Okay, so the perpendicular, the perpendicular vibration of the particles perpendicular to the direction is for the transverse wave, right? Okay.
Oh, okay.
So the particles vibrate parallel in the formation of longitudinal waves, right? So when the particles vibrate parallel, right? Parallel to the direction of energy transfer. So remember, so the examples, if we talk about the examples of longitudinal waves and transverse waves, so light is the example of light, X-rays, um, seismic, seismic waves, even all electromagnetic waves, all electromagnetic waves are transverse wave, right? And when we talk about the longitudinal waves, so first of all, we should understand the direction of the vibration of the particles. They are going to be parallel to the direction of energy transfer, right? For example, if the energy goes from this point C to D, right? So what are you observing? The direction of particles, direction of particles, direction of vibration. Okay, I should say direction of vibration. Direction of vibration of particles, of particles is parallel to what? Direction of energy transfer. And this is the direction of energy transfer. Direction of energy transfer, right? Right. Now, when we talk about the examples of longitudinal waves, for example, yes, the examples for longitudinal waves, uh, the sound waves, right? The sound waves, the p-seismic waves. Would anyone like to tell me what the p-seismic waves and s-seismic waves are? Anyone knows? Do these waves form due to the movement or vibration of the tectonic plates?
Yes, sir.
Yes. So when the plates move or vibrate parallel to the direction of energy transfer, so they produce the longitudinal waves, right?
Yes, sir.
And when the plates vibrate perpendicular to the direction of energy transfer, so they produce the uh, if it is perpendicular, they will produce S seismic, which is going to be example of transfer waves. If it is P seismic, so the plates will vibrate parallel, which is going to be a longitudinal. So the key term you have to memorize that parallel vibration is for the longitudinal waves, perpendicular vibration is for the transverse waves, right? I hope this is clear. Now, in all the waves, we have to understand what amplitude is. For example, if someone is speaking louder, right? So that means what is happening? What are we going to call that? Are we going to call it louder sound? Okay, but technically, in terms of waves, we are going to call it larger amplitude. The louder sound in the terms of waves, it is considered having a larger amplitude, right? So what amplitude is? What is amplitude? The maximum distance traveled, or we can say moved. Okay, the maximum distance traveled moved by the particles, or the maximum distance uh, covered from the baseline or from equilibrium position Now I'm going to explain this, what I have written so far. See, I have this wave, right? I have this wave, right? And I have this baseline, that means the horizontal line here, which is going to be a baseline or reference line, okay? Let me call this a baseline, reference line, or you call it equilibrium line, okay? Equilibrium position, right? So how far the distance is covered, the particle has covered, okay, in the wave. So we're gonna consider this one, this distance, the vertical distance, okay? This vertical distance is going to be considered as a amplitude, okay? Is this clear? This arrow shows what? This arrow shows the amplitude. Is this clear? Yeah, Marine, is this clear to you? Five,
Yeah.
is this clear? Hello?
Yeah.
So this distance, right? This vertical distance is considered to be an amplitude. Okay, now if I ask you to make a louder sound is going to have a larger amplitude, right? Okay, so first of all, we have to have a baseline here. We have to have the wave is a wave there. So how many lines the peak is covered? 1, 2, 3, 4, right? Now, in order to make a louder sound, what I can do is 1, 2, 3, 4, 5, 6. I can make it 6, right? So that it should be considered a louder one, okay? Clear? Right? So
Yeah.
you see here, this distance is maximum or greater than this wave. Let me call this wave A. Let me call this wave A. Let me call this wave B, right? Yep. So the wave B is louder, having the larger amplitude. Okay, so this is also the amplitude here. Okay, so what I can say, what I can conclude here, that the wave B is louder because louder than, we have to be very specific, right? I told you, okay, we have to be very specific while answering the questions. So wave B is louder than what? Than wave A, right? than wave A because it has larger amplitude. It has larger amplitude, right? Which is a vertical distance, okay? Clear now? That should be a vertical distance, right? Vertical distance in the waveform. I hope this concept is clear now. Okay, now what is the wavelength? Any idea? Type, do you have any idea about the wavelength?
No.
Okay. Marine, do you have anything to share about the wavelengths?
Yeah, it's the distance between two consecutive points which are in phase and have the same motion.
Oh, wow, great. Are you telling me the definition that I told you in the last class?
Like I worded it differently.
Oh, okay, fine. That's great. So now that is the actual concept of the wavelength, right? So yeah, Marine, could you please tell me what the wavelength is? The distance, right? The distance between
Two consecutive points.
the two consecutive points which are in phase. Okay. Now, phase means when we talk about phase, so phase is going to be the points which are in phase, they have same motion, right? They have same motion. I'm going to explain this. What does this mean? Same motion, right? Same motion, same distance or displacement. Okay, same displacement. Any other point? Wherein would you like to add? Same direction, moving in same
No,
direction.
that's it.
Same motion, same displacement.
Yeah, same direction.
Yeah, moving in same direction. Moving in same direction. All right. Now let me pick some pictures so that I can say insert here. All right. Now look at this one. So you can take any 2 point. Okay. Osama, could you please pick any 1 point on the wave? Let me allow you to annotate. Yeah, please.
Uh, this point.
Yeah, could you pick any 1 point? Oh, wow. You have taken the point which is at the peak. Type, would you like to pick any point from the wave? Pick any point. Type.
Yeah, the middle.
Okay, where can you please annotate? Oh, that's great. All right. Now you have chosen this one. You have chosen this one. Right? So I'm going to show you that how we call the points to be in phase, right? Okay, so first of all the points, in this, starting from here, so this is the source, this is going to be the source, right? The particles are moving up, right? Which is at this point, and then they come back, which is at this point, they go up, and then reaches to the maximum point, and then they come down, right? Now you have chosen this point, let me call this P, right? Okay, now look at the motion of this point, the point P, right? Is this point coming down? Is this point coming down? Yes. Is this point coming down? Yeah.
Yeah.
And now you are going to choose the same point. It has to be consecutive, right? Which is moving in the same way coming down, right? So when you go down, and then you have to go up, are you able to find out this point, or you have to move a little bit on the next level? Is it going up or is it going down? This one. Is
Going
this
up.
Q and P, are they in phase? Are P and Q in phase on the basis of this same motion, same direction? Are these 2 points in phase?
No.
No, because P is coming down and Q is going up, right? So when you go up, which is to this point, okay, and then reaches at the same level, okay, so we got this point, right? So what if I say this is going to be Q, okay? Let me call this one the P1. Let me call this Q. Let me call this R, right? So the 2 points are in phase. So the P and Q are in phase, right? Because move in same direction, right? Is this clear now? Yeah, having same motion, having same motion. So whatever the distance between these two consecutive in phase point, that is called a wavelength. What do we call it? What do we call it? A wavelength. Is this clear? Yes.
Yeah.
A wavelength is the distance between two consecutive points, right? This one and this guy, they are in phase, therefore the wavelength is going to be this much, right? Or can you take any other point? Yes, we can. We can also take this one. Let me call this A, let me call this B. Is it going to be wavelength? Yeah, Mehreen, is it going to be a wavelength between A and B that I have marked?
Yeah.
Yes, because they are in phase, right? Can I take this one and this one? Let me call this C and D. Are they in phase? Yes. Are they in phase?
Yeah.
So they have to be a wavelength as well, right? This is also wavelength. The wavelength is denoted by the symbol lambda. We call it lambda. Okay. Clear? So we can simply write lambda here. We can simply write lambda here. We can simply write lambda here. Is this clear? So lambda is what? The wavelength. And wavelength is what? The distance between two consecutive points which are in phase, right? Okay. Is this clear now?
Yeah.
All right. Now, what if I talk about the wave speed? Wave speed. Yes. Wave speed is the wave covers the distance per unit time. Okay. Clear? Right? That's going to be a wave speed. How fast the wave is, right? Okay. Clear? So wave speed is going to be is so the speed is denoted by V, and the wave distance is denoted by, we call, let me call it the speed right here, and let me call the distance first covered, and let me call this time, right? Now if I'm going to write the wave speed, so I have to have this V here. I have to have the distance covered by the wave is going to be the wavelength in terms of the wavelength, right? In terms of the wavelength, right? And this is going to be the t, small t. Now we're gonna start in the next class from here, okay? And we will talk about the frequency, and we will also drive the equation, wave equation, right? Where we will be talking about V equals to how this V equals to F lambda, where F is the frequency, V is the speed, and lambda is the wavelength. How this comes, right? Clear? In the next class, inshallah. Assalamu alaikum. Allah Hafiz. Yes, Zama, you can leave as well. Okay, assalamu alaikum, Hamza. How are you?
Alaikum salam.
Hamza, could you please join the class again? I'm just starting in 1 second.
All right.